Okay, so here we are in 10.1. And in 10.1, we are looking at two population means, but with unknown population standard deviations. So when comparing two population means, let's say comparing two population means is common, I'm sorry, because the population standard deviations of the two populations are unknown. One estimates them by using the two sample standard deviations from two independent samples instead. Okay, so when you have two population standard deviations that are unknown, then you can estimate them by using two sample standard deviations from two independent samples instead. So several criteria needed to be considered. One, the two independent samples are simple random samples from two distinct populations. And two, for the two distinct populations, if the sample sizes are small, the distributions are important. They should be normal. If the sample sizes are large, the distributions are not important, so they need not be normal. Okay. So the Texas Instruments and the NumWorks calculators have functions for two sample means when the population standard deviation is unknown. Now, when the population standard deviation is unknown, you're going to be doing a t-test. You're going to be using a student's t-distribution. So with the Texas Instruments calculator, under tests, it's the one called two-samp t-test. Now, one option that it asks for, which is different from the two-sample z-test, is that it asks you pooled yes or no. Okay, regardless of whether you're using the data or the stats. It says pooled yes or no. The NumWorks calculator also has an option for you to do a pooled t-test or just a straight t-test. Here what we're looking at are the inputs and the outputs for the Texas Instruments function. And you'll notice that it gives an extra output for the Texas Instruments. Okay, we don't have this on the NumWorks calculator. This SXP is the standard deviation of the pooled sample sizes with their sample standard deviations. This is called a pooled standard deviation. Okay. Presently, the NumWorks calculator does not have a way of calculating this automatically, okay, versus maybe calculating it manually. But what are we talking about when we talk about pooling two samples? So this next part, I've enclosed in a box because this is the short take-home message. If the population standard deviation is unknown, but the population standard deviations are assumed to be equal, then you're going to use a pooled test. So you're going to say pooled yes. If, however, the population standard deviations are unknown, but they're assumed to be different, then you do not use a pooled test. So you're going to put pooled no. Okay, choosing to pool two samples can require some evaluation of the samples. So some things you have to consider, and this is kind of this is kind of, some extended details here. So part A, the first sample size and the second sample size, are they both less than 30? Are they considered small? Or are the two sample sizes greater than 30? Are they considered large? And if they're large, are they not equal? And by not equal, we mean that the two sample sizes have a relatively different magnitude. So there's a difference greater than about 2 times. So for example, here we've got two sample sizes, one sample size that is 35 and another one that is 80. And we can see that both a sample size of 35 and a sample size of 80, those are both greater than 30. So that would be constituted as large. Also, 35 is not equal to 80. Okay, these are different sample sizes. And the second sample size of 80 is 2.3 times greater than a sample size of 35. So the unequal sample sizes are used to weight their corresponding sample variances. Scroll down a little bit here. Here we go. Okay. Okay, so the unequal sample sizes are used to weight their corresponding sample valence variances. So here we've got the variance for the first sample. Here we have the variance for the second sample. And you're multiplying the variance of the first sample times the sample size minus 1. And here we're going to add to that the product of the second sample's variance times the second sample size minus 1. And this creates a combined or pooled single standard deviation that we call standard deviation pooled. Okay, so the formula for a pooled standard deviation is this equation here. And it's from this equation that the test statistic is calculated using that in part. So this resulting test statistic incorporates the weighted average of two sample variances, which may not be equal. Now again, so the calculation of a pooled standard deviation, that does come out of the Texas Instruments calculator function of a two-sample t-test. But the NumWorks calculator doesn't do that. It doesn't have that as a native function. But to run a two-sample t-test, not a pooled one, okay, so this would be pooled no, is you go to the inference app, you go to tests, you go to two means, and as soon as you go under two means, you'll have the opportunity to do a t-test or a pooled t-test. So when pooled is supposed to be no, you'll just do a t-test. It'll then ask you for the null and the alternate hypothesis. You can put in the parameters of the two samples here, and it'll kick out a test statistic and a p-value. But when you are supposed to answer yes to pool the standard deviations or the variances of the two samples, then at this point, you're going to choose a pooled t-test. Choose your null and alternate hypothesis, enter in your sample statistics, and then it'll kick out a test statistic and a p-value. Um, so I believe it's calculating the pooled standard deviation, but it doesn't output it. And I don't know of a way to get to it otherwise. So right now, getting that value is not something that I'm aware of can be done right now. That this could change in the future if I make a MyOpen math problem that'll calculate that. And of course, I'll let you know if I end up doing so. Okay, so we need to do some examples. This just gives you a heads up of which calculator functions you'll be using, and when to do a pooled and when not to do a pooled. And again, some examples will help clear that up. All right, thank you. Let me know if you have any questions.